In last few lectures, we are discussing Python programming and its applicability in this present course. So far, we have discussed how to write pseudocode. Then we talked about fundamentals of Python programming. And finally, the numpy library and its use in scientific computing. In this lecture, we'll take a short exercise in numpy, and the result that will be generated by numpy, we'll plot it using another very useful Python package that is called matplotlib. We take up an exercise of cooling of an insulated rod. So this is our insulated rod AB. The rod is insulated from the periphery. The rod has a length of 1, and at x equal to 0, the temperature is 0. At x equal to 1, the temperature is again 0. However, initially, the temperature of the rod was 1. So the problem is that if I have an insulated rod that can only transfer heat from two sides, I cool the rod by suddenly subjecting both ends at temperature 0 when the initial temperature 1. What will happen to this rod temperature? Now, we are not much concerned about the problem now. We are not going to solve it. Rather, the solution of this problem, it is possible to have an analytical solution. And here you can see temperature as a function of time, and the location x is given by an infinite series, that is 4 by pi, summation from 1 to infinity, only the odd integers, and here it comes 1 by n exponential minus n square pi square t sine n pi x. How this solution appears, that is of course a discussion of heat transfer. However, later on in this course, you may see a numerical solution of this problem, and at that point, we'll discuss the numerical solution of such problem. But right now we are not concerned about the numerical solution or any solution at all. Only thing we want to do here is to plot the results. But to plot the result, first we'll generate a data file of this temperature, and then we'll plot from this data file. Of course, before we plot this result, or if you are solving this problem, before you can actually solve this problem, you have to think about the problem and think about that what that solution might look like. So here you see that the initial temperature of the rod was 1, and suddenly the boundary temperatures are brought down to 0, which means that the temperature inside the rod will continue to drop, and the temperature will reduce inside until the inside temperature at all points that will match the boundary temperature. Which means if I plot the temperature here, let us say that this is my t-axis and this is my x-axis. So here I have my B and here is my A. This is the rod. And initially temperature was 1 and suddenly it was made 0 at the end. So this is my initial temperature, T equals 1. This is my initial temperature. And when I make it suddenly 0, both end comes to 0, this A and B, and the temperature inside will then begin to fall. So after some time, t equals 1 is initial, that is time t equal to 0. So this is time t equal to 0. We have a straight line here, but then the temperature will begin to fall, which means that it will be like this after some time. Then it will be like this after some time. Then it will be like this. And thus, this is my time. And as the time progresses, the temperature will continue to drop. So this is a kind of plot we call temperature profile. As the time progresses, we can see that the temperature everywhere will continue to drop. And eventually, if we go long in time, then temperature everywhere will be more or less zero. And that is where the process will stop. So now let us go to the matplotlib and see that how we can plot, how we can generate the data file and plot the results. So when we generate the data file, please try to understand that this t as a function of time and x, this is a continuous function here, but when we will generate the data file, it will be discrete. So we will have the values of temperature T only at certain time and at certain x. And when we do so, T as a function of time and x, I take discrete data, it will be a two-dimensional array in numpy. So let us see how it goes. So here we have written the equation, and this equation we are interested to plot. So to plot this, first of all, we need this package matplotlib, and I start from there. So we will use this pyplot package, and I'll encourage you very much, you keep on typing this code with me if possible, and that would be an easier way to learn this. And of course, for the calculation part, we need numpy. Now we have to think about the discretization of this function. Now this function is in time and space. So what we do here is we have to take number of time steps. So we define a variable number of t and we arbitrarily set it at 21. Then we discretize in x direction between 0 and 1 and at some point. So number of x, once again we arbitrarily set as 101. We'll need this term pi square for calculation, so we better have a pi square calculation done. So pi square is equal to, we need a math package to define pi, but numpy also defines all these math functions. So np.pi multiplied by np.pi. Now we have 21p, and this 21p will be distributed. So we take this time t as linspace. It starts from 0 and we'll develop this number of t means 21 points in time, and you have to do a bit of a trial to see that up to which time you'll go, because if you set the final time pretty large, then everything will be 0, you won't be able to see anything. So I'm giving a small time here, and we have to see doing some trial that if we are right. So I have created an array of time. Now I have to create an array of space. So that would be my x. In the same way, this is np dot linspace. This of course goes from 0 to 1. And I'll take this number of x, this many data points. The temperature I'm writing is as u, just not to avoid confusion with this time t and temperature t. I'm writing it as u. So u, these are only zeros. I'm initializing as a numpy two-dimensional array. So this is number of t, number of x. This big an array is my u. So now I want to calculate this u. So let us see that what it is. U is coming with a 4 by pi, and then there is a series I have to add starting from 1. So this is actually n equals 1. So I have to add starting from 1 to infinity only the odd numbers. So I cannot add up to infinity. So I have to take some value where I'll truncate this series. So we assume this limit of this summation. Usually after first few terms, the remaining terms will not add much. But just to be on the safer side, we take lots of term here, 1001. Only the odd numbers between 1 and 1001. We will add them. All right. Now we have to sum this series. And you can see that this series has two parts. One is this only time dependent part, this 1 by n exponential minus n squared pi squared t. And second one is the space dependent sine of n pi x. Okay. So the time dependent part, let us say I name it as ut. So what will be this ut for certain t and x? The ut will be, now we are using this vectorized operation, and my vectorized operation is that np dot exponential of minus n square pi square t. So minus n pi square t. This is my ut, and similar to that I'll have an ux that will be sine n pi x np dot sine n dot np dot pi multiplied by x. So if this is the case, this is for certain n, we have not summed up yet. For certain n, this is the ut and ux, then it has to be added over different n's. But for some n, this is the ut and ux. Therefore, my u will be whatever the u value I have plus this ut and ux. We have to multiply them. This both ut and ux are vectors, because t is a vector, x is a vector, or in other sense that t is an one-dimensional array, x is also an one-dimensional array. So ut is an one-dimensional array, ux is also one-dimensional array. So we have to multiply this one-dimensional arrays and make a two-dimensional array. So this is a vector-vector multiplication. That means ut ux transpose, which means this is an outer product of vectors. So the u will be u plus np dot outer ut ux. But then I have only taken this exponential and this sign. I did not take this n, so I have to divide it by n. Now this three statements that I have written here for ut, ux and u, I have to sum it up for different values of n. So for that, I write for n in range 1 to limit of sum plus 1, because we can go up to 1001. But then it's from 1 to limit of sum plus 1. We are not taking all the numbers. We are only taking the odd numbers. So there will be a step of 2. This is my for loop. Then I have to indent here. Whatever the u I have calculated here, this is sum of this series, and I have to multiply 4 by pi with this sum to get my u. So I have to now come up out of this for loop. So I have my u, which is equal to 4 multiplied by u divided by np dot pi. So this should be the final matrix or final two-dimensional array. Now I have to plot this result. To plot this result, I will plot only at few times, maybe 2-3 different time, and my time goes from 0 to 20. The number of t is 21, so it goes from 0 to 20. So I'll plot only few of them. So let's try this plt dot plot x. I take this 5, that means starting from 0 time up to 5, I take one of the line. So this is my first temperature profile, and matplotlib will set a default color. So I'm giving a color. For instance, this is blue. Then I follow the same procedure and I plot time step 7 and I make it black. I again follow the same procedure. I plot time step 10 and I put a color green. Then I can give a title of the plot. So my title would be temperature profile. How big will be the title? We can also set. There are several attributes we can set, but the font size is sometimes important. So font size is 20. Similarly, we should set the labels in x-axis and y-axis. So this will be my x label, and my x label is simply x. I can keep similar to the x label. I can set also an y label of t, that is my temperature. Then I save the figure. It may be necessary. Saving figure is not necessary to see the figure, but it may be necessary to use the figure in other documents. So most of the time, you will see that you need to save the figure, and you can set the resolution. So here I am setting the resolution of 300. Now we have to see that how it will go. So let's just check it out. We have to write this plot.show to show the plot here in this notebook. Another error here. Okay, now you can see that we have plotted the results. So this is my temperature profile. Blue was initially, then it becomes black and green. So T, the temperature here at y-axis. So you can see that temperature is coming down toward 0. Now we can also have a contour plot of temperature. We can see that how it is happening over the entire time and x. So to do so, we can have a contour that is plt dot contour xtu. Then I put a color bar so that we can understand what color means what temperature in contour. Plot title temperature profile. Sorry, this is not profile. This is temperature contour. And we keep the font size of 20. X label, Y label, we'll keep it that way. Here I change the name of the file and I put contour here. So this is where we can have a contour plot. So you can see that this is a contour and this is only the lines you can see, but you can flood also with contour F. So now you can see that it is flooded. 0, this violet type color is 0 and in most places it is 0. So as the time progresses, you can see that it is becoming more and more 0. Only here you can have some temperature, but then it is more and more 0 it is coming. So this is how we can plot the temperature contour. Let us now go back to where we were. The figure that we shaped there, those figures are here. So first figure is the temperature profile, where we observe that it starts from T equals 1 and then with time the temperature is dropping, everything is going toward T equals 0, and very similar information you also get from temperature contour. So these are the ways you can plot this function. This is a two-dimensional array in discretized form, but this is a function of two variables, two independent variables, t and x. Now to close this session, we have seen a numpy exercise and we have done our first plotting in Python. Many more exercises can be done and during this course we'll do them. But for now, you can go to this matplotlib website and see some of their tutorials to learn more about plotting. That's all for this session. Thank you, and I'll see you in next class.